Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Fikrie and I'm from Group 4. Today I want to explain to you about the satellite communication system. Firstly, the introduction part. So what is a satellite? Satellite means a smaller object that revolves around the largest object in space. And communication is the exchange of information between two or more entities through any medium. Satellite communication means communication take place between any two Earth station through a satellite. And next, before and current satellite application. So before, the old day they are using the telescope to see the space, but current we are using satellite communication to see into the space better and further. The signal are sent up, down, and can sent to a different location in the world. The application current we use is TV, phone call, internet, something like that. So basic concept of satellite communication. First, we have a station in one place. For example, place A, to transmit the information, the source information into the satellite. That we call that the process is uplink into the satellite, and the satellite we transfer to another station, which is B station. We can call it output information. This process is we call that downlink. Yes, downlink. Okay, that's a basic principle. And the signal transmitted through the space as an electromagnetic wave and carried by wire as the voltage or current, like analog and digital, also have generated by a computer. Separating signal up and down, we are using the FDD, frequency division duplexing, TDD, time division duplexing, and polarism. Between user, and we have FDMA, which is frequency division multiple access, and TDMA, time division multiple access. CDMA is code division multiple access, which is we are using this for our communication system. So digital communication system also have a module so the first one, we have a transmitter module, which is in the transmitter module we have a source data, source coding, and channel coding, modulator, and to transfer to the RF channel. And from the RF channel we receive the information. So the information we go to demodulation and channel decoder and source decoding, and we are getting the output data.
Assalamualaikum, I am Aiman Syafiq, and I will explain about satellite system elements, which is categorized by two segments, space and ground segment. And in the phase segment, we have phase, satellite, and subsystems. For space segment, there are 5 phases overall, which is the first phase is satellite launching phase, the second one is transfer orbit phase, deployment phase, operation, and lastly the retirement phase. Okay, for the space segment stabilization, there are 2 stabilization that we considered, which is spin stabilization for spinning an axis with a maximum inertia. The second one is 3-axis stabilization, for a bias momentum type and zero momentum type. For the last segment, which is space segment subsystem, there are two subsystems with communication, consists of antennas and transponders. The second one is a bus subsystem, which is telemetry, satellite control, propulsion, electrical power, structure, and thermal control. For the ground segment, this is the figure of Earth station. From the satellite transfer to the house and others factory. The next one is I will explain about specification of satellite system. Consists of frequency spectrum and also the microwave frequencies. Also commonly used band, space earth frequencies usability, and lastly the insights on frequency selection. For the frequency spectrum concepts, there are 5 factors. The first one is frequency, which is a rate at which an electromagnetic wave reverts its polarity. The second one is wavelength, the distance between wavefronts in space. The third one is frequency band, for the range of frequencies. The fourth one is electromagnetic spectrum, size or width in hertz of a frequency band. The last one is bandwidth, full extent of all frequencies from 0 to infinity. In the microwave frequency properties, they are from 1 GHz until 30 GHz. For the line of sight propagation, space and atmosphere, blockage by dense media, wide bandwidth compared to the lower frequency bands, compact antennas, directionality possibility, reduced efficiency of power amplification, radio frequency power out, direct current power in. For the third one is commonly used bands. This is the figure of the bands. There are terrestrial bands, space bands. Shared with it consists of those two bands, terrestrial and space. For the space earth frequency usability, this is the figure of the frequency wave. The resonant frequencies are below 100 GHz. For the H2O, the frequency are 22.2 GHz. Meanwhile, for the oxygen, the range of the frequency are between 53.5 until 65.2 GHz.
Okay, now I would like to present about application of the satellite system, which there's two parts, which is the first part is current geo satellite application, and the second one is MEO and LEO satellite application. For the first part, current geo application satellite, there's 3 application used in the current situation. First is broadcasting. For example, is used for television such as DirecTV or Prime Star. And the second one is point to multi-point. For example, is used by VSAT or video distribution for cable television. Okay, and the last one is mobile services, where it's used by Motion, former American mobile satellite, or Inmarsat. And now I would like to explain about MEO and LEO satellite application. First one, for MEO satellite, is mainly used for GPS. It will broadcast pulse trains with very accurate time signal, and it can calculate its position within 30-meter radius from its receiver. And then second part is LEO satellite. It's a new. There's two new systems in 2000, which is circular orbit with less than 1,400 kilometer altitude, and the satellite travel across sky from horizon to horizon in 5 to 15 minutes. Now I will explain about current development and future trends. There's one part only for this subtopic where I will compare current development and the future trends. Okay, first, the current trend in the world is right now tend to make a bigger, heavier geosatellite with multiple roles. The second one is more direct broadcast TV and radio. The third one is mobile service, and the fourth one is internet. The future trend for satellite communication is with growth. For satellite communication to growth, it requires new frequency bands. The next one is future trend will try to make a low cost phase antenna array. Okay, this part is for conclusion where I will explain about advantages and disadvantages of satellite communication. First, for the disadvantages, it can be received by anyone under them. Second one, it have either a limitation for visibility over a spot on Earth. And third one is it has a long round trip time. And the fourth is affected by terrestrial and space weather. Fifth one is complex from both a physical and regulatory point of view. And last one is subject to a higher error rate than a fiber. But on the other hand, it has more advantages, which is available almost everywhere on Earth without wires. Second one is being the perfect broadcast medium. Third one is being mobile, and the fourth one is being protocol agnostic.
Now we would like to talk about stakes. What is stakes? Why it is important? Will it solve our current problem? And how it works? State system is referred to the satellite terrestrial integrated mobile communication system. It shares the same frequency band between the satellite and terrestrial system to improve the spectrum efficiency. The handheld terminal is used with a large satellite antenna for the voice data communication. Meanwhile, for a compact terminal is used for the small satellite antenna for the data communication. In stick system, the frequency is assumed between the 1980 until 2010 MHz, and also within the 2170 until 2200 MHz. These two frequency allocation strategies is divided into normal mode and reverse mode.
This system leads to the unloading fixed part of the mobile network. Next, the channels can be reused in cells. Other than that, the cross-channel interference is below the tolerable levels. Finally, an additional increase in network capacity can be achieved by a further division of the territory into smaller cells. What is the application of sticks? Sticks can be implanted by marine to detect other ships. Next, military can use sticks to detect weapon or vehicle from enemies. Finally, it can be used for weather forecast. That's all from us. Section 10, Group 4. Thank you.